1. We have ignition, and we have liftoff.
Contact with the spacecraft launched in 1977 was lost when a wrong command was sent, tilting its antenna 2 degrees away from Earth.
Deep space just dropped a revelation we have all been holding our breath about, and it comes straight from NASA's longest-running explorer. Voyager 2, the spacecraft that's been sailing beyond our solar system for decades, has confirmed something that scientists had only whispered about before. The signals it sent back aren't just data. They may be proof of a terrifying truth about what lies out there in the cosmic dark. Could Voyager 2's discovery finally explain the strange turbulence it entered? Or has it uncovered something that changes how we see the universe forever? Join us as we uncover Voyager 2's shocking confirmation. On August 28, 1989, NASA's Voyager 2 spacecraft sent back what would become its final photograph, a haunting image of the planet Neptune with its distant moon, Triton, hovering nearby. The spacecraft was already more than 4.7 billion kilometers from Earth, yet its cameras captured a moment that has stayed with scientists for decades. The picture showed Neptune on the left and Triton off to the right, frozen in a quiet cosmic dance. Soon after, the cameras were turned off for good, not because the mission was finished, but because the dwindling power supply had to be conserved for more important instruments. The image itself carried a strange beauty. When Voyager 2 took the shot, the sunlit sides of both Neptune and Triton were turned away, leaving their faces in shadow. Instead of the bright, colorful worlds that had filled earlier photographs, what came back was a dim, ghostly view. The probe was already moving beyond Neptune's orbit into the vast darkness, and the picture seemed to capture not only a planet and its moon, but also a farewell, the closing of one chapter in its mission and the opening of another. Scientists later reflected that it marked the end of close-up planetary exploration by Voyager 2, and the beginning of its role as a silent witness to the outer reaches of our solar system, where it would measure charged particles, magnetic fields, and the streams of plasma at the solar system's edge. Through the turn of the new century, NASA's Jet Propulsion Laboratory continued to receive valuable data from Voyager 2. In January 2001, for example, the spacecraft picked up evidence of a massive shock wave that had burst out of the outer heliosphere the year before. The wave had spent 6 months traveling through the solar wind, sweeping up charged particles along the way, and Voyager 2 was there to record how those particles were accelerated and energized. This kind of data helps scientists understand just how violent and powerful the environment beyond our planets could be. Years later, in August 2007, Voyager 2 crossed the termination shock, entering the strange region known as the heliosheath. By November 2017, the spacecraft was more than 116 astronomical units from Earth, which worked out to about 10.8 billion miles, or over 17 billion kilometers. It was moving at a steady speed of 9.6 miles per second relative to the Sun, on a path that would eventually carry it toward the constellation Telescopium. At that pace, scientists estimated it would take nearly 20,000 years for it to travel just 1 light year. Even after decades in space, the spacecraft still surprised its handlers. On July 8, 2019, Voyager 2 successfully fired up its trajectory correction maneuver thrusters, engines that had last been used 30 years earlier during its Neptune encounter. The decision to use them again showed just how carefully engineers worked to extend the life of the spacecraft, ensuring it could still be pointed in the right direction to send data home. But then something happened that caught everyone off guard. Voyager 2 began sending back signals that did not look like the ordinary fluctuations of space plasma or the familiar waves of magnetic fields. Rather, it was bouts of activity and these weird pulses that could not be attributed to any familiar astronomical phenomenon. Initially, NASA turned it off as interference or maybe a glitch. The trends were regular, however, with time. They were not disorderly, but nearly rhythmic, with intervals, as though the spacecraft was gathering some order. To the listeners of the transmissions, it was no longer the silence of deep space. It felt like Voyager 2 had entered a zone of turbulence unlike anything they had encountered before. Privately, some scientists described the signals as sounding like a heartbeat. Others quietly wondered if it was possible that an intelligent source was involved. Then, in early 2020, the spacecraft went completely silent. For 7 long months, not a single transmission came through. Recurrently, NASA described the issue as an improper alignment of the antennas, which could be rectified over time and by sending commands through the vacuum. But there were rumors that the final signals sent by Voyager 2 before it lost contact were not the appearance of an antenna malfunction. Insiders hinted that the probe had sent what appeared to be coded messages, fragments of information that no one outside a very small circle was ever shown. To the world, the official story remained simple. Voyager 2 had slipped out of alignment, fallen silent, and was later brought back into contact. But for those who had seen the final transmissions before the blackout, the memory lingered. It was as if the spacecraft, after traveling billions of miles away from Earth, had brushed up against something humanity had not yet learned to name. Voyager 2's journey did not end with its eerie final photograph of Neptune and Triton, or even with the strange signals it later transmitted. Its story stretches further back and further forward, covering almost half a century of discovery, endurance, and mystery. The spacecraft was first launched on August 20th, 1977, as part of NASA's ambitious Voyager program. At the time, the idea of sending a machine across billions of miles to study the outer planets felt like a leap of imagination, as much as a feat of engineering. Voyager 2 left Earth just 16 days before its sibling, Voyager 1, and together they were designed to take advantage of a rare planetary alignment that would allow them to slingshot from one world to the next, using gravity assists. Voyager 2's path took it first toward the great gas giants, Jupiter and Saturn, and then onward to the more distant ice giants, Uranus and Neptune. No other spacecraft has ever visited both Uranus and Neptune, making Voyager 2 unique in human history. Because of the trajectory chosen, it was destined to be the only spacecraft to see those strange blue worlds up close. Scientists said at the time that its mission was like peeling back a curtain on worlds that had always been dots of light in a telescope, but never places with real landscapes, weather, or moons to study in detail. By 1979, Voyager 2 reached Jupiter, the largest planet in the solar system. It sent back photographs that stunned people on Earth, images of swirling storms, massive lightning bolts, and moons so active they seemed almost alive. One of its many surprises was the discovery of a 14th moon orbiting Jupiter, a small and previously unseen body circling the giant planet. It was proof that even in a place humanity had studied for centuries, there were still secrets waiting to be found. 2 years later, in 1981, it made its closest approach to Saturn. There, it added to the growing list of discoveries by revealing the richness of Saturn's rings and providing close views of its moons. But it was in 1986 that Voyager 2 did something no other human-made object had ever done. It became the first spacecraft to fly past Uranus. It was the first time when scientists could observe that it was not only a featureless sphere, but a complex world with its rings and moons. Voyager 2 uncovered 10 new moons and 2 faint rings that had never been detected from Earth. The spacecraft showed that Uranus tilted on its side in such a way that its magnetic field was completely different from those of the other planets, baffling scientists and inspiring decades of research that followed. 3 years later, in 1989, Voyager 2 repeated history by being the first spacecraft to fly past Neptune. It found not only 5 new moons and 4 additional rings, but also spotted an enormous storm system in the planet's atmosphere. Scientists compared it to Jupiter's Great Red Spot and called it the Great Dark Spot. Unlike Jupiter's storm, which has raged for centuries, Neptune's Great Storm was later seen to vanish, a reminder that these distant planets are not static or silent, but dynamic and changing. All these experiences contributed to the impression that Voyager 2 was not only a machine sending information back, but somehow of an explorer who took human interest to uncharted waters. Having finished its tour of the planet, Voyager 2 continued. Though it had fulfilled its original mission of studying the outer planets, NASA extended its purpose. Its new role was to travel even further, to keep measuring the invisible forces that shape the boundary between the solar system and interstellar space. By November 18, after more than 4 decades of flight, Voyager 2 crossed a line that astronomers called the heliopause, the edge where the sun's protective bubble of charged particles, the heliosphere, gives way to the raw environment of interstellar space. It was now in the interstellar medium, where there were plasma and magnetic fields, as well as the self-galactic radiation. Voyager 1 had been well beyond this mark 6 years prior, but Voyager 2 had something quite new that was the first direct measurements of the density and temperature of the interstellar plasma. It was like dipping a thermometer and sensor into a sea humanity had only imagined before. By May 2025, Voyager 2 had traveled a staggering 139 astronomical units away from Earth, which equaled about 20.8 billion kilometers. It still kept in touch with the Earth even at that unimaginable distance via the NASA Deep Space Network. A single antenna in Australia, the DSS-43 dish near Canberra, bore the responsibility of listening for its faint signals and sending commands back. The fact that humans could still talk to a spacecraft nearly 13 billion miles away was itself almost as astonishing as the discoveries it had made along the way. All this happened as Voyager 2 was burdened by the fact that it was not only a scientific tool, but a messenger. Similar to its twin, onboard it had the famous Golden Record, a collection of sounds, greetings, and music on Earth that was to be played in case any intelligent beings might find it someday. Scientists tended to refer to Voyager 2 not alone in terms of information, but as an agent of humankind itself, a small machine that had penetrated into the darkness with hints about our presence. But where there was the official version of victory, there were the disturbed and mysterious incidents which continued to puzzle people. The strange magnetic variations and plasma measurements, the pulsing that some have suggested was like a heartbeat, and the great silence in 2020, which was attributed to an antenna anomaly, but whispered rumors at one time that it might be something better, all created an extra aura to the story of Voyager 2. There were even whispers being made by insiders that immediately the spacecraft had been heading towards the dark side. It had relayed what had been thought to be coded messages. This was never substantiated by official reports, but the thought was like a shadow that hung at the periphery of its otherwise splendid history. What is certain is that Voyager 2 continues to drift outward, carrying its instruments, its discoveries, and its mysteries further into interstellar space. It is still inside the solar system because the sun's gravity holds sway for trillions of miles, but it has long since left behind the planets and entered a realm where no human eye will ever see it again. Is Voyager 2 warning us about deep space dangers? Or is it pointing us toward a greater discovery? Leave your thoughts in the comment section. Also like, share, and subscribe for more exciting videos. Click on the video on your screen and you will love it.